We are good to go.
All right.
Okay.
All right. I'll go ahead and read that one. And suppose we had a set of paired data and let D equals XA minus X before, or excuse me, X after before X before. The null hypothesis is H, or the null hypothesis, the deviation equals 0. Excuse me, not deviation. The alternative hypothesis is, forgetting what that one, does not equal 0, and the population standard deviation is not known. Jordan collects a sample size n equals 9 and computes D equals 2.2 and S equals 3.3. What is the value of this test statistic? Okay.
So we need to plug it into the quantitative inference procedure.
Mm-hmm. Does not equal 3.
Got T is equal to 2.0.
Okay, you're using the paired sample t-test one, is that correct?
Yeah, paired sample t-test, 95% confidence level, null hypothesis is equal to 0, and type of test is not equal to.
Okay, and so I have N for 9, but where are you putting the 2.9 and the 3.3?
So 2.2 is the mean, and 3.3 is the standard deviation. Because
Okay.
it's the standard.
2.9 is the mean,
deviation.
3.3 is the standard deviation, right?
Okay, that is just
Okay. So it's D bar is the mean.
gotcha. Okay.
Sample deviation is 3.3.
For some reason, the notation was escaping me tonight. So 2.0 is what I get as well.
Yep. Do we have to do 3 decimal places there too?
Doesn't say anything about that.
Okay.
Remember to round 3 to 3 decimal places, unless otherwise specified. So I'm going to go ahead and put the 3 in there. Okay. So for question 4, it says the probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
Is it 0.04?
Yeah.
Oh, wait. Oh, that's the test statistic. Okay.
So 0.04. Okay. Okay. Are we looking at the p-value that we've already calculated, or? Man,
That's what I was thinking. I think the t-value is different, right? So when you plug in the t-value, or the test statistic is 0.0403, and then just get the p-value from that.
sorry, my brain is really off tonight. Where are you planning on plugging in the 0.0403?
Well, it says that the test statistic is 0.0403.
The probability of obtaining a test statistic greater than that is 0.403.
Right. So then, wouldn't that be where you plug in t?
Yeah, so the test statistic t is labeled on the horizontal axis. The p-value is the area. To the left of t under the curve.
Okay, so the apple.
This is two-tailed, so it would be the area under both curves. Yeah, I think he's right. So you do enter in.
Now, is that probability the area? And
Yeah,
something greater. Okay, so we want to have the right of that statistic.
Well, no, this is a two-tailed test because it's not equal to. So you take both tails would be the p-value.
Mm-hmm.
Right?
Yeah, that's right.
0.806. 0.0806, which is what the p-value is in the test, correct?
I'm getting something else.
Me too.
Okay, so you plugged in the 4.0. Oh, I had it.
I'm getting 0.9681.
Are you guys plugging this into the Excel file?
So I'm using the normal probability applet.
Okay.
Oh, okay.
And where are you plugging that in for the area?
Yeah, to the z-score. The z-score and t-score are figured essentially the same way.
You get 0.968. Is that what you get?
Yeah.
Okay, I was just putting it into the area instead of the z-score.
Because the area is the p-value, isn't it?
Yes, it is.
Right.
So we're trying to find the p-value. So we'd need to put in.
For the t-value, gotcha.
Into the z-score. Yeah.
Okay.
0.968.
I could be off base, but that's.
It's logical to me. If we're wrong, we're at least wrong together, right?
Yeah. Yeah.
Okay, chapter 12, data A1.
All right.
So I can read this one. It says, use the data file, chapter 12, the data file to answer the next 6 questions. Perform a paired samples t-test and SPSS. Be sure that the test does group 1 minus group 2. Use the null hypothesis of that of mu, an alternative hypothesis, and level of significance is 0.1.
Okay.
Is our alpha.
Mm-hmm.
So our confidence level is supposed to be 0.90,
Right.
and then you just plug in the variables.
Mm-hmm.
Does group 1 minus group 2.
Okay. Group 2.
Okay. And for our T statistic, I get 0.407. Is that what you guys get?
That's what I've got too.
I think. Let's see. Is it still greater than, or I guess I missed something here?
It's not equal to.
Oh, not equal to.
Yeah, you always use the alternative hypothesis. In this case, it comes right out and says it. Alternative hypothesis mu is not equal to 0.
Oh, not equal to 0.
Oh, and make sure you remove your mean, standard, and n from the other problems.
Oh, okay. That's what I got. Okay, so T is 0.407.
Yes.
And we're using a 0.9 confidence level.
Right.
Correct.
Okay. Cool.
Wait, why do you say 0.9 instead of 0.1?
Because the confidence interval is the 1 minus the level of significance, right?
Yes.
Oh, gotcha.
Okay. P-value then is also 0.688 or 0.689.
Yes.
Okay.
Okay, 0.684.
0.684.
Yeah.
I get 0.689 as well.
Using 0.407.
Right.
T is 0.407.
Are all of your values put in? Correct, Sharon?
Yeah, well, that's using the probability applet too.
Okay. I'm wondering what.
So we have p-value 0.689 based on the Excel file, but if we're using the probability applets 0.684.
Okay, which is more accurate? Do we use the applet then?
No, I would just use the.
I'm going to use Excel.
Yeah, the applet seems like it does. I mean, it doesn't go out as far, right, as far as decimals.
Yep.
Okay.
Okay, I'll take this one. Question 7. What is the correct decision based on this evidence? It's even
Not equal.
greater. So I would say we fail to reject the null hypothesis.
I'd agree with that.
Okay. Suppose your alternative hypothesis is instead alternative hypothesis is UD is greater than 0. What is the correct decision based on this evidence? And our p-value is changed to 0.344. And options are, we have insufficient evidence that the mean and difference is equal to 0. Okay. We would have insufficient evidence that the mean of the difference is greater than 0, correct?
That's what I would think.
We would have insufficient evidence that the mean of the differences is equal to 0.
Is greater than 0.
Oh, is greater than 0.
So this is the alternative hypothesis.
Yeah.
Mm-hmm.
So
Okay. Wait a second. is greater than 0.
Yeah, I would still say that it's insufficient evidence.
Or is
The
it
mean is different.
What's that?
I would stay with the same answer.
Okay. Wait, so why I'm just curious. So how come there's insufficient evidence that the mean of the differences is greater than 0?
So your null hypothesis states that it's equal to 0. Your alternative hypothesis in this case says that it's greater than 0.
Mm-hmm.
So in order to prove this, in order to prove the alternative hypothesis true, you'd have to reject the null, which means you'd have to have a p-value of less than 0.1, which we don't in this case. But we'd say that we have insufficient evidence to prove the alternative hypothesis true.
Okay. Okay. Yeah. Thanks for explaining that. That makes sense. All right. I think it's my turn. Use the data file, chapter 12, data B1, to answer the next 8 questions. Perform a paired samples test, t-test, in SPSS or Excel. Be sure that the test does group 1 minus group 2. This data comes from nosocomial infections spreadsheet. The null hypothesis is H naught equals mu D equals 0. The alternative hypothesis is the mu D does not equal 0. And the level of significance is alpha equals 0.01.
That's a very high confidence level there.
Yeah, 0.99.
Yeah.
So which is greater, n or degrees of freedom?
I'm gonna plug that in real quick.
And
Degree
is
was n minus 1.
yeah.
Oh, right. Okay.
Group 1 minus group 2.
All right. 0.99 confidence level does not equal 0. The type of test is not equal to 0, right?
Yes.
Not equal to, yes.
Not equal to, okay. Which is greater? N? What do you have?
It's always going to be your n because your degrees of freedom is found by taking 1 from n.
Oh, yeah. That makes sense. Yeah, exactly. So, yeah, I just counted them out to verify too. It's 22 n or sample size, and then the DF is 21. So, yeah. So it's n.
So
Okay.
what is the p-value now?
It's 0.001.
Mm-hmm. Okay. What decision do you make?
Because it's technically equal to it at that 0.001 rounding, I would still say we fail to reject the null hypothesis.
No, in this case, it's 0.001. So it's actually
Less than?
less than.
That was a good catch.
So I think we would.
Oh, you're right. I misread.
Yeah, it looks so close. I mean, one decimal place.
Okay.
Mhm.
So in this case, we would reject the null hypothesis.
Yeah.
Right,
Thanks.
because your p-value is less than alpha.
Thanks for catching that one, Aaron.
No problem. Okay, I'll take this one. You decide to try another alternative hypothesis. This time you use alternative hypothesis mu is greater than 0, and you keep the same level of significance. The p-value increase or decrease.
Okay, greater.
It
Decreases.
Decrease. Yeah.
increases.
I'm like, so I was just looking back at the number that I got, and I feel like I've got a different answer.
For
than you
which
guys.
question?
So for the last question that we did, so it's probably because I just did it wrong, but let's see. So what is the p-value? And you guys said 0.001.
Mhm.
So when I plugged mine in, I got as the p-value in there 0.0034.
Hmm.
So I don't know what I did wrong. I'm using that the Excel file that they have, right? Is that what you guys are using?
What's your confidence level?
0.99.
And your null hypothesis is 0, correct?
Null hypothesis.
Hmm.
Where did you set that? Because like
Right
mine,
under
I
the-
have
Yeah, under the confidence level.
Yeah.
I put it as not equal to
And,
as the
okay.
type
Right.
of test is what it has.
Hmm. What did you say your p-value was?
0.0034. I'm wondering, did I put the groups into the wrong columns?
What do you have for your variable 1 in row 5?
69.
And you have
What's
30.
what's your difference?
What's the difference?
Yeah.
I'm not sure. It doesn't calculate it on the page.
Oh, it should.
Yeah,
Yeah,
so
yeah.
that's really the only thing you calculate is the differences. Once you've calculated the differences, the
So you guys
variable are not even used anymore.
Maybe I'm using the wrong sheet.
If you're using the paired sample,
Oh, a paired
t-test,
sample. Okay, I'm using the 2-sample t-test right now. That's what's going on with it.
Oh, okay.
Okay,
That
that's
would-
why
that would
it's not
change
coming
it.
up right.
hmm
Okay, then you guys are right.
I'm glad you're asking. We get to go over these together because it helps me get it more ingrained in my brain.
Definitely. Agree.
Okay. Now,
On 13, I think. Unless,
yes.
did you get those other ones together?
Yeah, so let's see where I'm at. I just fixed it, so now I got the same answer as you guys. So for question 10, I got 0.001. 11, you guys said, what was it? Reject the null.
Right.
Mhm.
And then
Decrease.
for 12. Okay. And so what decision do you make?
We'd still
You-
reject.
Yeah, reject it because it's still smaller.
Yes.
Okay.
The p-value.
Okay, and so 14. So based on your response from the previous question, what conclusion do you make?
Sufficient.
I would say that we would have sufficient evidence that there's a mean difference between the two groups.
That's what I would say, because if there was no mean difference, then we would fail to reject the null. Is that right?
Right.
Okay.
So it's the third one down. Then we have sufficient evidence that there is a mean difference between the two groups.
Mhm.
As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the same p-value?
The smallest p-value? I'd say not enough information.
Yeah, I think so too.
Seen the p. Okay.
Because the p-value would depend on things like the confidence interval and stuff like that, right? not whether or not it was not equal to, greater, or less than. Is that right?
Well, so the p-value doesn't change when you change the confidence level,
Right.
but it would change, depending on the differences in whatever test you're taking or doing. But
hmm
in this particular case, the
I
greater
s-
than.
I still think it's greater than, because if you change the null hypothesis to something besides zero, like say like 2, you're still going to have the greater than being your smaller amount. But that is just for this one, so I'd agree that the third question is probably the smartest one to go with.
Yeah.
I don't know. Typically in the past, though, too, I mean, this is maybe a little unrelated, but there's a way you can determine that without the numbers. Like usually, I mean, with that there's a rule that's set, but maybe we could try this and see if it's right, and kind of trial and error.
Okay.
Cool.
For this next question, we're supposed to determine the 95% confidence interval for the mean difference between the two groups. And then for 16, what is the point estimate for this 95% confidence interval?
Okay. Point estimate.
Okay. So basically we get the confidence interval and then we find the middle point, correct? Is that what we do to get the point estimate for the 95% confidence interval?
I think so. I need to review that, but I think that sounds right. Point estimate.
So the point estimate of a 95% confidence interval, does that go back to the z-score of that number where it's like 1.960?
I'm not sure. I think it.
Because I
I'm
think,
reading.
is the z-score the point estimate of a confidence interval?
Okay, so a point estimate of a population parameter is a single value used to estimate population parameter. For example, the sample mean x bar is a point estimate of the population mean mu. So a 95% confidence interval would be x bar.
That's what I was looking at. You're in lesson 10, right?
Yeah.
Reading, the lesson 10 inference for one mean. So I was looking at that because I'd remembered that it had that little table, and I think I'm wondering if that's what that means.
It's chapter 10.
Yeah. Because then it wants us to calculate the margin of error
Mhm.
using that formula, which we would then use that number, right?
Right. Okay. Okay, so it says we can create an interval by estimate by starting with a point estimate and adding or subtracting the margin of error. Let's see. I don't see where it says to calculate it. Kind of what Nathaniel was saying, where you take the midpoint.
Yeah, so you take, I guess, yeah. Where's
Do you remember? Nathaniel? Do you remember that in the textbook?
Well, you
That's
have
what
the
I guess.
confidence intervals in lesson 10 or section 4, where it has the X bar minus the t scored times point estimate of S. So I'm not really, well, S is the sample standard deviation. Okay. So that gives us the confidence interval where X bar would be the point estimate or the mean, correct?
Mm-hmm.
So I think the midpoint is what we're looking for.
Which in this case is 11.955, isn't it?
That's what I get as well.
That's what you got for the midpoint between the two?
Yes.
Because we're just looking at the mean.
Right. 11.954 or 955.
Yeah.
Yeah.
So you can
Oh.
take the confidence interval and you can.
Oh,
So
you can
do
just use the
1/8.
mean. You can use the mean of the differences for the point estimation.
Yeah.
Right, but the mean of the differences is going to be, that's just the mean. Won't it be the difference between the mean and the high or the low confidence interval that would then be your
It's the same thing. I did the
your
math
margin
as
of
well.
error?
Yeah, I just did it.
So it's 11.955.
Right.
Oh, okay.
And what is the margin of error?
Yeah, I didn't mean to question you with that, Nathaniel. I just wanted to double check.
No, I'd prefer triple checking, in fact.
Okay, cool. Good, glad we're on the same page. Okay, yeah, margin of error. Is that different from the standard error of the mean, or do we have to calculate that?
I know there was a formula for that one, but I don't remember if it was in this lesson or the last lesson.
That's why I was confused when I was asking you 11.955, because I was talking about the margin of error rather than the point estimator. I forgot we were still talking about the point estimator. So what I was thinking is what you do is you take, so the difference between the high and the low interval, divide it by 2, and then that would be the distance from the midpoint to either the high or the low. And that difference is the margin of error. Is that right?
That's what we got for the point estimator.
Now, see, that's just confusing because I don't know.
Although I see what you're saying, it does make sense though. But then what would the point estimator be?
A margin of error.
Two times standard deviation divided by the sample size is the formula for that.
Yeah. So we take a confidence interval, which is in this case is 0.95, And that gives us the z-score of 1.96. Then our standard deviation is, what is it on this one? Standard deviation is 15.003.
003. Mhm.
And then the n is how many on this one?
22.
Yeah.
Two. Okay, I get a margin of error of 6.269.
Oh, I got close to that. I got 6.39. Let's see. So you did two times standard deviation.
No, what I did is I have the z-score times the standard deviation by the square root of n.
Which standard deviation did you choose? The standard.
Yes.
Yeah.
So 3.199 divided by the square root of 22.
But that may be wrong because that's where I went off on my homework.
I'm looking at the formula here in lesson 10, and it says to multiply it by 2, not the z-score.
If you look further down, that one will say that one's for more specific to have a better.
Okay, I see it. Yeah,
have it closer. You
confidence
want to
interval.
use the if you
I
want
see
it
it now.
better, you want to use the 1 point, whatever
1.96.
from the z-score. Yes.
Okay, good catch. Okay, so you got 6.269, or was that 1.96 was the z-score, or what's the z-score on that? Sorry.
Z-score is 1.96 because it equals 0.95 confidence. So z-score is 1.96. So your standard deviation is 15.003.
Mm-hmm.
Your n is 22.
Right.
And then your m is going to be your z-score times your standard deviation divided by the square root of m of n.
Right. You said your standard deviation was 15 point something.
0.003.
Where did you find that standard deviation? I guess mine's totally blank. Is what's weird is like my numbers are in, so I'm getting the differences, but the summary statistics table is blank.
Summary statistics.
So let's see.
That is blank.
You're supposed to, if you look down in the third table, they'll have variable 1, 2, and differences on the left column. You go over to the third column N, or fourth column N, actually, it says standard deviation on top. And if you go down to differences, the differences row, it should be 15.003.
So mine is 3.199. That's
standard error.
You're looking at standard error, not standard deviation.
Oh, what the heck am I doing? It like, okay, I'm sorry.
Mm-hmm.
I just totally missed that. I'm like, what is that number?
No worries. And then so that is 6.269.
Correct. So that's what I have as well.
Okay.
Then we get to input the lower bound. Yay.
Cool. And we should just have that, right? The 5.303?
Correct.
Yes.
Cool.
And the upper bound should be 18.607, correct?
Right.
Mm-hmm.
Cool. Everybody get that?
Yep.
Awesome. Anybody feeling extra confident to submit today?
Yeah. Gonna be good. I'll go ahead and do it.
Oh, okay, cool.
Question 4 is wrong.
Uh-oh.
Question 15. I put greater than 0. So that was probably my bad.
I put, oh yeah. Did we change it to not enough information? Or
I believe that's what I have.
It was not enough.
Is not enough.
And then question 17, the margin of error is wrong.
That stupid margin of error.
So 4 and 17 are showing up as wrong.
Okay. Let's go look at 4 because that's probably the one we'll have more luck with.
yeah, good call. Number 4. With this one, I was thinking I got a different answer with it just by plugging in the t statistic. It messes up the formula, but I mean you can undo it after you put it in. If you just plug in 0.0403, it gives us something else.
Well, and the thing is it's asking for a test statistic greater than his test statistic, not greater or less than the probability of what would land in there. So I went with the applet and just selected the area above the z-score.
What I thought we ended up, didn't we decide on clicking both sides of it?
We did, but we're looking for something that's greater, not something that's less than.
Oh, okay, so just greater than, not both.
And that's what I'm thinking is the way to go.
Okay, yeah, that's worth a try.
Okay, so
What was the answer for 3 and 4 then with that?
3 is 2,
Okay.
and 4 I have 0.484 using the applet. And then for 15, we got to find out how to do the 17 margin of error.
So 17, I think it's 6.652.
Well, that's what we just put in.
Oh, wait,
I think we had 6.269. We had something out.
Oh, yeah. Okay. Okay.
How do you get that, Skylar?
So what I did is I did 18 point, hold up. I just got rid of my numbers, so I don't know which numbers they were. But I took the upper bound minus the lower bound, and that gives you like 13 point something.
You divide that by 2.
Uh-huh.
Okay.
So I can submit that and just see what happens.
Wait a second. Okay, so it says in okay, so it's the plus or minus percentage. Okay, so we have so it would be my guess would be that you're right on the 6.652, because we're looking at what's to either side of the mean.
Yeah.
And what did we decide with 4? I thought we
4,
we
ended up going with my idea, at least thus far, of doing just to the right of the z-score, and that gave me an area of 0.484.
484, right? Okay.
to the p-value.
Okay.
Okay, so here, let me submit it and see what happens. Okay. It looks like everything's good.
Really?
Yep.
It's exciting.
Now, if I just figured that
Oh,
one out on
no.
Saturday,
That's not
get one
true.
wrong?
So four is still wrong.
Uh-oh.
four's wrong. But 17 is correct.
But yes, 17 is correct.
Okay.
So we need to figure out the probability of a test statistic.
Probability of test statistic. I say we just, you know how they give you that data in the problem up above? What if we plug all of that in again and then just plug in again where the t value is, or the t statistic, we put the 0.0403 and see how that affects the p-value on the paired sample test Excel sheet. Unless someone else has another idea, that's what I think.
Okay, so you have the data that we had initially, and then you're saying change
The
what?
t statistic from whatever it was to the point. What is it?
0.0403.
Yeah, 0.0403.
So what did you guys get for question 17?
6.652.
Right, how did you guys figure that out?
It's
So you
half.
take-
It's half of the confidence interval.
Yeah, so you take the upper bound and subtract the lower bound from that by 2.
Okay.
Okay.
Okay, mean.
So we're just working on question 4 now.
Yes.
Okay.
So what's the mean in that question?
The mean is 2.2.
2.2. Okay, that's right. All right. Sample size is 9.
And the standard deviation is 3.3.
And for the null hypothesis, you plug in
0,
the 0 there.
and it's not equal to.
Right. Okay. And then so from there for the p-value, so is that 0.0805?
That's what I currently have for the p-value, yes.
Okay, cool. Now if we take,
Wait, wouldn't it be 1 minus the p-value?
for the test statistic, or excuse, yeah, or
The probability of obtaining something
for the
greater than
p-value.
this would be 1 minus our current p-value, right?
Oh yeah. Determine the p-value. Wait, use the probability to determine the p-value. Use this probability to determine the p-value.
So,
I'm kind of
Okay.
gonna go out on a limb here and kind of see if I can throw something in the mix. So, just looking at the grid sample t-test, if you put in the mean at 2.2, standard deviation 3.3, sample size at n, and then choose greater than as the type of test, it gives you 0.403 as the p-value. And number 4 asks the probability of obtaining a test statistic greater than Jordan's test statistic is 0.043.
which is what you get there from rounding.
Yeah. Use this probability to determine the p-value for Jordan's hypothesis test. So if you do the greater than test and take that t-value of 2.0 and plug it into the applet, and then choose the greater than, which is to the left, you end up with 0.0228.
Why I don't get that. So you do 0.04 for that area, or it was a z-score, right?
He said
Take the t-score and put it in where the z-score is.
in the applet.
Okay.
So 2.0 is the t-score,
Okay.
and then
And
the area
left.
shaded to the left,
So that's 0.0228.
0.0228.
Which it rounded to the third decimal place is 0.023.
Right.
0.023, right? Okay.
So if I'm understanding, the only difference between a test statistic, like a t-score, like I don't know if you could call it a t-score, yeah, t-score, and a z-score is just the type of test that you're performing.
Yes, one is where your deviation, I think the big difference is part of the problem is known with the z-score and part of it isn't. And I believe
Okay,
that's the
gotcha.
population standard deviation, I believe, is what is known when you use the z-score.
Okay.
Because they're both calculated the same way. Yeah.
Right. So the normal probability applet should work. Like it should be interchangeable for both.
For t-score or z-score.
Yeah.
So I'm going to go ahead and submit with that change.
So that's 0.0223.
0.023.
Oh, 0.23. Yeah, sorry.
0.023. Yeah, and I'm at the point where even if I don't
Yeah.
get it right, I'm done for the night.
I hear you, man.
And that is not the correct answer for 4. But we basically exhausted all that we could think of to try to do that. So unless you guys want to try something else, I think we should just call it a night and try to find out from like the TA or something like that.
I'm going to do 0.9772 and just see what I get for that.
Oh wait, won't
Okay.
that use your other try though, Aaron?
But yeah, I don't know if somebody else wants to try it, that's fine too. But if not, I'll just do it.
I'll try it for you.
Okay.
So what was it? 0.997?
0.9772.
977. 978, right?
977.
Oh, 77. Okay. 97. These answers, man, drive me crazy.
Yeah.
Okay, submit. No, I still got it wrong.
Oh,
Well,
All right.
I'm going to go ahead and end the broadcast and go ahead and post this, guys. Okay?
Okay.
All right, sounds good. Okay, good work, guys.
Oh, what time do we want to meet? Do we want to meet tomorrow or on Thursday?
Tomorrow works for me.
Let's leave.
Actually, either day would work for me.
Unless someone's got a time constraint on Wednesday.